So last time we have successfully installed the database engine and we have installed the Microsoft SQL Management Studio, and it is time for us to build up a database. However, before we start building a database, we'll first need to understand a couple of basic rules about building the databases and building the tables inside the database itself. So unfortunately, this means that I will have to show you a few slides to explain a couple of things. So let's quickly start with a table design. So what is very important for the table design is a simple and clear naming of those tables. So this also stands for the databases. So the database name shouldn't be anything super complex like some generic name with the numbers or anything like this. It should be something really meaningful. The same goes for the tables, for the story procedures afterwards, views, etc., etc. So quite simple, I believe, to follow. Then the next thing is normalization. So normalization itself is a design technique that enables reduced redundancy of the data. So normalization itself, it's essentially a set of rules which divides larger tables into smaller tables, and then we'll link those tables using relationship. So in most of the cases, those smaller tables are the data sets that are reusable for different rows. And we're going to jump in the example of normalization very quick. The next thing would be to define clear constraints. So the constraints are set of rules implemented on a table in relational databases to dictate what data can be inserted or updated or obviously deleted. So constraints are everywhere around relational databases, so we're going to work with them, and probably you won't even notice that we're working with the constraints. Then the next thing would be to use the correct data types. So using the correct data types is essentially crucial for good analytics, but also for keeping our databases as small as possible size-wise. And let's just learn a few things about the design of those columns. So for instance, when we are designing each of the columns, we're specifying the type of that column. So we have, I just put here on the slide, so a couple of, I would say, most important data types that you should use. So obviously we have unique identifier. This is in most of the cases a good candidate for a primary key for the table. Unique identifier corresponds to the GUID from the C#, so essentially it's exactly the same type. Then every time when we want to describe certain text, we should use nvarchar. And you see here that there is an N here, which means you can actually specify the size of this character, which is constraint itself, right? So why nvarchar? Because nvarchar can store any Unicode data. For instance, if you compare it with varchar column, varchar type, it is, I believe, restricted to the 8-bit code page, which makes him also a bit dependable on a collation. And this is a fight which you really don't want. You don't want to fight with this issues in the future. Then we have a date and time, and we have date time 2. So obviously, if you first time looking at a SQL, you will say, okay, probably there is a date time without 2, and you would be correct. Why date time 2? So date time 2 has a larger date range. It has also larger default fractional precision. And obviously you can specify the precision as well just by providing a level of precision that you want to do. And obviously if you provide, let's say, a bit smaller precision, which would be still same or equal as a date time, we would use a bit less storage for saving this value. And one of also the coolest things for the date time 2 is that the date range is from year first, I believe. up to the 9,999, which is not really the case for datetime, because datetime only supports the date, I believe, until some date in 1753, something like this. This is the minimum, the year that you can use, and there is a bit of a historical reasons for this, and you know, I challenge you actually to Google this out. It's quite interesting. Then if we want to save the whole number, we're going to put integer itself. So this is a quite good way to store it. There's also a bit different types, like a big int, but int is a memory wise a bit better solution. But still, if you have some huge numbers, then big int could be a way to go. And for decimal numbers, you know, for the it's suggested to use decimal, and you can specify here also the size of this decimal. But this is something that we are going to look into it. There are additional data types. There are really a lot of data types here in the SQL. For instance, for the date and time, I didn't mention if you want to save date only, you can use SQL data type of date. For time, you also have time. You also have money type. You have binary options as well, although I do not suggest at all to save the binary data like MP3s or videos or images into the SQL Server database at all. This is going to blow up your database quite quickly, and this is something that you really don't want to do. So now I believe as you have now understand the basics of the designs for the SQL tables, we can go ahead and create our database. So I'm connected now. Actually, I opened my SQL Management Studio, and I'm just going to quickly connect to the database engine, and we have installed instance of a SQL Express, and I'm just going to use the Windows authentication to connect to this database engine. So I'm going to click connect, and right ahead you can see that we have our folders listed here, well, virtual folders, right? So under the databases, you will see that we have a couple of system databases, and you know, there are 4 system databases, and I actually already have opened the link for you for those databases, so you can learn a bit more about them on the link itself. So you should not even try to delete those databases. I never tried. I don't even know is this even possible, but they're essentially necessary for you to work with the SQL. So just leave them as is, and yeah, probably your master is going to be your default database in the system. So now it's time for us to create a database. And before we do this, what I did is I essentially prepared a small Excel file. And this Excel file is containing basic information which we want to replicate to our SQL Server database. So if you take a look here, you will see that there are a couple of columns that we have, like a first name, last name, date of birth, etc., which we need to put inside our tables on the SQL Server. We also have one more tab here, which is called language proficiency. And here we have additional table, which is essentially telling us which user for which language has which kind of proficiency. So where 10 would be probably the largest amount of proficiency. So now what I want to do is I want to just take a look at this slide quickly. So in the previous minutes, we discussed normalization, and this is one of the key elements of the relational tables, relational databases, sorry. So if we take a look here, the question is what kind of information could we essentially extract and reuse for some of those records? So if we take a look at a first name, it doesn't really make sense to create additional table for the first name because the first name is kind of unique for the users. And yes, maybe we will have 5 Johns in the system, but if one John changes his name to Michael, then we don't want to change all the others Johns to Michael. Last name, the same. Date of birth, again, quite dependent on the user itself in this case. And now we have account type. an account type, as you see, it is kind of repeating for different rows. So now the account type could be actually a pretty good candidate to extract those records inside different table. And that here in the rows, we're just using reference to the account types. So the benefit of this one would be that in a case, let's say, that we have, for instance, if we want to rename business to something like company, we would change this in only one table, and all the accounts would have the account type of company. So we don't have to update all the records here where the account type is business, replace it to company. So this is a quite good candidate for the extraction. The another one, email, again dependent on the first name, phone number again dependent, and then when we go to primary language, we see exactly the same case as we see with the account types. So again, we can extract this to another table. Is active, last login created on, all of those records are essentially dependent on the record. We could obviously create one more table, for instance, for those two fields, and we can call them contact information. But due to the it's just the two columns here, so for us at the moment it wouldn't make any sense. So if we would have, I don't know, Facebook, WhatsApp, secondary email, fax, all those fields, then it would make sense, you know, to extract this to another table. But I will not do this in this scenario. So let's just go ahead quickly and let's go back to our SQL Management Studio, and I'm going to create a database by doing a right click and saying new database. So for the database name, I'm going to specify something friendly, and I can say that this is company contacts. Okay, it's probably a bit of a stupid name because yeah, it doesn't. Let's just call it employees, something like this. This actually makes a bit more sense. So now when I did this, you see here that I have two database files. So what are those database files? So we have one database files which is called often MDF. I really like to call it MDF. It's a cool abbreviation, and it stands for main database files. So main database file contains all the information in the database. The other file is LDF, so it's log database file, and it records all the transactions and changes to the database. And the LTF file, those guys here, they're critical for disaster recovery. This is really important. Now, initial size of the database. So if we expect to have a lot of data, we can put this to any number we like. Obviously, considering that our disk is has free space to store this file. And then the another one would be auto growth. So essentially, if our size goes above 8 megabytes, then we will get additional 64 megabytes allocated, and there is unlimited size which this database can grow. And this is exactly the same scenario with logs. So the path, the default one, stands exactly there where we installed our where we configured our installation of the SQL Server. So this is all good. And now we can just quickly go to the options, just to quickly explain you what do we have here. So collation is being inherited again as a default collation from the database engine, and then we have a recovery model. Now, recovery model is quite important thing for you, not really on this basic database design, but you will notice that we have three possible recovery models. So we have a full, bulk logged, and a simple. So essentially, depending on how this database is critical for your work, you can choose one of those three recovery models. Full recovery model, I will just explain full one, is essentially all the transactions that we do in the database engine are recorded in the transaction log file. This obviously means that transaction log file is going to get really large quite fast. But this also means that the sequence of log is preserved for the database restore operations. So in the case that something goes wrong with a database, we can restore it using the logs, and we can, it's quite important for the database recovery. So I'm just going to stop explaining it right there because I don't want to have overwhelming session, and I'm just going to press OK button to create a new database. And as you see here, the new database has been created. Now I'm going to expand it a bit by clicking this plus button, and you see a couple of folders here. What is interesting for us is tables, and I'm just going to expand it a bit, and all of those folders are going to be empty now. So we're going to store all our data inside the tables, and then afterwards we can build diagrams, we can build story procedures, etc. But now we're just talking about tables. So let's quickly go again to our data set, and we see that we need to create a user table, right? Because we want to store the first name, last name, date of birth, etc., etc. So what I'm going to do is I'm just going to create a new table by doing a right click on tables, choosing new and saying table. So this gives us designer way of creating tables. So be aware, everything that we do in the designers is going to be translated to the SQL in the background, and this is going to be executed as a simple query to the database engine, and we're going to obviously our records or tables or everything of this is going to be created. I'm just going to use a designer now because, in my opinion, this is first of all how I do it every time. But database designers in this case are quite good, and there is absolutely no need for you to use Transact SQL in this case to create a tables, because it is quite okay to do it in this way. And I will explain you afterwards how you can create those tables also with the SQL. So now when we look at a table, well, it's empty. What do we need in a table? We would need to have a primary key. So what is a primary key? A primary key is essentially a certain identifier of each row. So if you look at, for instance, your credit card just look at a credit card. It has a certain unique identifier. If you look at your Facebook ID or Twitter ID, they're all different. And this uniquely identifies certain records. It's same here in our case for the users. We don't have it right now. If you look at this Excel, we don't have any IDs, but how would you get a certain person? How would you know to get John Doe here? So you have to say, okay, give me the person where the first name is John, the second name is Doe. But what if there are two of them? So you cannot be 100% precise. You would have to provide everything about this user to get exactly the one, and even this is not a guarantee. So what we do here, we're going to just create a primary key, and I'm just going to call it ID. And the data type of this can be essentially anything, but what I like to use is I want to use unique identifier. And obviously for primary key, I'm not going to allow nulls. So if you are not familiar with the nulls mean that this column will have no value. It's not empty string, it's not empty text, it's not zero, it is null. So no value behind this record. How do we make this primary key? We just do a right click here and we set a primary key. By the way, multiple columns can represent your primary key. It doesn't necessarily need to be one. So now let's start writing our columns from the Excel. So first thing that we have is first name, then we have last name, then we have date of birth, then we have account type, then we have email, phone number, we have primary language, we have is active, we have last login, and we have created on. Okay, so now we have all those records here, and we should actually specify also the data types, because not all of them nchar 10. nchar 10, as I previously explained, you know, for the text we should actually use nvarchar, and this is exactly what I'm going to do right now. So I'm just going to update the data types to something that makes more sense. So I'm going to use here an nvarchar of, let's say, 150, right? So 150, this should be sufficient for every name, every first name, and I would do the same for the last name. So what does this mean, 150? 150 means that this column will allow a maximum of 150 characters to be saved for the column. If you have more than this, obviously the remaining characters could not fit in this limit. Date of birth, we said previously that we have datetime, we have datetime 2, but we also have date. We don't need a time when someone got born. The account type, I'm just going to skip it for now, and let me also put for the email in varchar 150. Hopefully this is going to be enough. For the phone number, I'm just going to use, I guess 50 would be more than sufficient for all the cases. I'm skipping the primary language as well, because we said that we're going to create this as a separate tables. Now for isActive, this is a Boolean value, and the Boolean value in the SQL is called bit. Last login, I'm going to just use datetime 2, and I'm going to give the precision of 5, and I'm going to do exactly the same on the created on. So now I just want to allow set the constraints for those records. So if we just quickly remind ourselves to all the columns, you will see that all columns mostly have the value, except the phone number, which has null values in some cases. So what I'm going to do is I'm going to say that the first name is not, the value null is not allowed, not allowed, not allowed, not allowed, not, yes, not, and not. And now in the designer, we can also do a bit more magic. We can specify some default values and create it on. So every time when we create a record, I can say get date. So this is going to put the value here. Actually, now when I look at it, the last login should be actually not allowed, because even if we create a user manually, it doesn't necessarily mean that he logged into any of the systems. So this can be set like this. Is active, we can say that is active, the default value is going to be, let's say 1. So the Boolean, as you know, is 0 and 1, so 1 is going to be active. And let's say, what else do we have? Let's say the ID, the primary ID. If you want to get a new GUID generated, you can just call the function new ID. And this is going to create you the new ID, so you don't have to specify explicitly the value for the ID. It will be just generated automatically by the SQL. So now what I want to do, I'm just going to save this table, and I'm going to call them user. We also said that we're going to extract the account type, and we're going to extract the language itself from this table. So if you're wondering why this table was not created, you can just refresh it here and it's going to show up. So let me just create more tables, and the first one that I'm going to create is going to be, let's say, account type. Again, I'm going to create a primary key. This is the ID, and I'm just going to put name for the language. So unique identifier and nvarchar 50, this should be sufficient. Both of those values, I'm not going to allow null for them, and I'm just going to say that the ID is a primary key, and what I'm going to say is that new ID is a default value for the unique identifier. I can save this, and I can say that this is an account type. So now in this table, I will save all the account types. And you will see it's quite simple. Okay, another table that we're going to create is essentially the same as this one. It is language, and all the information that we need for a language is a primary key and a name. So I create a new table, and I say that this is ID, and then name, and then I say here unique identifier, say here and varchar 50. Both of those values don't have null, and I set this as a primary key. Again, new ID is the default value, and I call this one a language. That's it. Perfect. So now the question arrives, and the question would be, how to connect the account type and the language with the user table. And you would be surprised how easy it is. So if I go again to the designer for the user table, I will see here that I have account type and I have also primary language. So first of all, what I want to do, what I like to do is I like to add ID for all the references that I'm using. So I would say primary language ID and account type ID. In this case, I can easily identify all the records that are, all the columns that are used as a foreign keys for the table itself. So let's think about account type ID for a second. So now, how do we connect the users with the account types? So we connect them by the key, and the key, which is very nicely visually interpreted here, is also a primary key, and the primary key is a type of unique identifier. So essentially a value of the primary key is going to be value of this user as well for the account type ID. So to connect those tables, we will actually use the data type, which has to be the same. And in this case, this is unique identifier. And it is going to be the same for the language because the language is essentially the same table. So we write this as well as a unique identifier. Great. So now let me just save it quickly. And now what I can do is I can add a reference between those two because we just now have the same type, but we still haven't connected those two tables. And how do we do this? We just do a right click and we say relationships. And now we can create a relationship. So I will create new relationship by choosing add option. And on the tables and columns specification, I'm going to click here and then I'm going to press those three little dots. And here I can choose the primary key table and foreign key table. So if I want to connect account type, which I should do first, I will choose the account type table and I'm going to choose the primary key of that table, which is the ID. And this ID is going to match to the account type ID in the table user. And I'm just going to confirm this by choosing OK. If I choose, for instance, date of birth and try to confirm this, it will tell me that the data types are not correct. So they're not matching. So now I will just fix my error and I'm going to say account type ID. I'm going to confirm it. SQL is happy. I'm doing it again because I want to do the same for language, and I'm clicking those three little dots and I'm choosing a language table, again the ID, and in foreign table I'm choosing the primary language ID. Great. I'm going to click close, and now you see I have unsaved changes in all those three tables, and I'm just going to click, I can save it here, and it will warn me that the other tables are being affected as well, because now the other tables will get relationship to the user table. So I'm just going to say yes. And if you have fresh setup of the SQL Server Management Studio, you might get error right now. And to fix this error, you can just go to Tools, Options, and Designers, and then you have this Table and Database Designers under the Designers, and you will probably have this checked. Prevent saving changes that require table recreation. Just uncheck this one and press OK. So then you will be able to save as expected. Perfect. So now we have successfully created our database, and the next step would be to fill it in with a bit of a data. But before doing this, I would like to also explain you how we can quickly show how this relationship actually look like. And to do this, we're just going to use database diagrams. So to create a database diagram, we can just go ahead to our database and we can choose the database diagrams here, do the right click and say new database diagram. And now we're getting a bit of a wizard look like. And it asks us which tables do we want to include in this diagram. So obviously we don't need to include all of the tables, but in our case, we have just 3 of them and I would like to include all 3. I'm just going to click add, I'm just going to close, and now you see the relationship between those tables. You see that the account type is connected with the user and then the user is also connected with the language. So this gives us, I would say, quite clear understanding how those tables are connected, and what we can do here, we can, I would say, even give this as a documentation to some of our colleagues so that they can better understand the schema of the database. Now what we can do, we can just try to create some of the records, right? This would be quite a good way to continue. So let's say for the account types, how do we create a record? I can just do, again, I'm going to use just the tables. I'm not going to use any SQL at the moment. So I can do a right click on the table and I can say edit top 200 rows. Now what I can do here, I can just say, what did we had? I believe we had private and business. Yeah, so private and then business. Great. So you see the IDs are null still, but you have this red item. This means that the record was actually successfully created, but this value is going to be generated. So we can just press this icon here to execute, and then you will also get all the information about the remaining columns being filled, because we specified the default value here. Now for language, I'm going to do the same. I'm just going to edit top 200 columns, and I had English, I had German, and I had French, and I had Croatian. Okay, so I had those 4 languages, and if I do the same, you will see I have IDs successfully created. Now, how do I create values for the user? So the user itself, if I just edit the users, I see the values are empty. So I can create a first record, essentially this one, and I can do it for John Doe, and I will say here, John Doe, date of birth, let's say 10 of November, I don't know, something like this. And then the account type ID, I'm just going to copy the value from this grid. So the account type ID for John Doe was a business. So I'm just going to copy this one and I paste it here. The email was john@business.com. Phone number was null. Primary language was English. So I'm just going to choose the English ID from here, copy it and paste it here. Is active was true, so 1. Last login was 21st of November 2021, and created on was 1st of November 2021. Hit enter, and we have successfully created our record here. And this we can do for all the other records. So now what I would like to do as well is just to explain you additionally how the other options of managing this data. So the first thing obviously which you can do is you can do this all manually, and unfortunately this is going to take a bit of a time. So you really don't want to do this manually because it's quite error prone process, and you want to automate this as much as possible. So you can obviously import the data from the Excel to the SQL. You can even create a new tables which is going to match the schematics from the sheets of the Excel list. You can import from different data sources like a CSV files or even, I believe, some web services. There are a lot of connectors. But what also you can do, you can, I'm just going to try to explain you the way using Transact SQL. So how do you do this? You can create all this using queries as well. So using queries, you can also create tables. For instance, if I want to script this language table, I can just do right click and I can say script table as create to, and I will say in a new query in the editor window. So if I want to create a table of a language, I can just script it out in the new query. And now this is the script language that I get. Mine looks a bit overwhelming at the beginning, but if you look at it, it is, if you remove those boilerplate codes, you will see that actually here is quite important part. And you will see that this is more or less like English. So you say, okay, create me a table of a language with the columns ID, which is going to be unique identifier, and the name is going to be varchar 50. Both of them are not null. Constraint is going to be a language, which is a primary key. This is the name of the constraint, and the column is going to be ID in the ascending order. So if you're looking at this, you see the reason why I actually use Designer, because if I want to tweak something additionally, I can do this using the script. But to write all this values here, it is a bit of overwhelming. But what if I would have one more table which has similar schematics to this one? So I could just replace the language in all of the obviously here cases. I could replace it with something like this. I would say, let's say that we have user type, something like this. Let's say language would be replaced with user type. I'm just going to replace it all in the current document, and I'm going to just go ahead and press F5. So the F5 is saying command completed successfully, and if I just go to the tables and refresh it, I will see that I have a new value here, which is a user type. Be aware that this script just creates a schema of the table. It doesn't have any records here. So you can, this is the reason why the script is very powerful. So you don't have to go click through all the designers and everything. You can quite automate the whole process of creating those tables or anything actually in the SQL. But sometimes it's a bit easier to do to work with a designer and to design new tables like this. So I'm just going to delete this table right now because it just quite stands there, and I don't want to use it. What else can we do with the SQL? We can create a new row for the user, because now if we select top 100 rows here, you will see that we're getting a bit of a script, and then here we have our results. So the results here are essentially saying, okay, this is the ID of the user. The system generated this ID for us. We have date of birth, we have essentially everything, and we have references to the primary language ID and the account type. So I'm going to explain you how to manage those when we talk about joining the tables. But now let me just quickly explain you how to create records with a script. So let me just write a bit of a script here. So I'm going to say insert into users table. User table. So this is quite interesting. The user itself is a keyword. So if you use this like this, it will complain a bit. So you put this in the brackets, and then the SQL will recognize this as your own type. And after I write insert into, I'm going to specify all the columns where I want to insert the data. So I would like to do this for first name, last name, date of birth, account type, email, primary language is active. Oh, sorry, email, phone number, I forgot. Phone number. Primary language is active, last login, created on. And I'm going to say select, and now I can say Amy, and Amy is going to be actually Mo. Date of birth, just going to put it as well as a string, so the system should cast it on its own. 11th of November 2000. Account type ID, I believe this is a private one, so let me just copy this one, again pasting it as a string. Then for the email itself, I'm just going to copy it from the Excel. This is going to be this. Phone number, we said this is a null. So primary language, I think it's the same as this one. Yeah, it's English. Is active is 1, so yes. Last login, I'm just going to use a function here, like get date, and for created on, I'm just going to use this one as well, so I will not pass it. How do we execute this? So those are two queries. One is to select, the other one is insert. So I can actually just select what I want to execute, and I can either click here on execute, or as suggested here, I can press F5. So let me just click here, and you will see that one row has been affected. If I select again all the records from my table, I'm going to get 2 records now. So essentially, we were able to insert this data. Now, why is this important? It is important to understand how the system works, because you will essentially, in your applications, you're going to use this kind of a script to insert the records. So now, obviously, my strong suggestion would be not to write this kind of code, so SQL code in a C# or in any other language. I hate mixing the languages. So we would use either certain mappers that will translate our statements inside the SQL code, or what we would do as well, we could use something as a story procedures to insert these values inside the system. But as you see right now, we have successfully created our database. We're able to import the data to the system, and yeah, everything works as a charm. Obviously, there are different ways to import the data inside the SQL. You should not do this by hand, as I did it here as an example. The reason for this is, it's error-prone way. It's a slow way. Now you have a different statements here in a script. You can actually copy from table to table, or copy from, you can auto-generate a lot of data if you want. You can insert multiple rows at a time. For instance, now if we just want to add a new one, we can even copy the statement, or there are really different ways to do this. But usually what you would do is, in a case where we do have an Excel with a data set, you would essentially import this data. So you have another ways to import the data from one data source to another data source, but this is completely different topics, and it's quite complex topics, although in our case it looks quite simple. So if we look at all this, we can say that our database has successfully been created. We can do whatever we want. Now, the only thing that we actually forgot to do this, we forgot to create one more table, which is called language proficiency. And this table is quite a cool table. The reason for this, it's actually going to represent something which is called many-to-many relationship. This means that, if you look at here, John Doe as a user here can be connected with multiple languages. So this is, you can have mix of the records and mix of the combination between two different tables. So, sometimes in your career, if you're working as a software engineer or anything like this, you might have seen here, like, I don't know, phone number 1, phone number 2, phone number 3, phone number 4, etc. For phone numbers, okay, having a couple of them makes sense. But for languages, in this case, potentially, if you're a really, really smart person, you can know like 5, 6, 7 languages. And it would be stupid to limit this in a schema of the table with, let's say, proficiency language 1, proficiency language 2, proficiency language 3, etc., etc. So what we do, we create this kind of tables, and then we can connect two tables, in this case user table with the language table, and then in this case we'll have just one more column here, and then we can add as many records as we want, as many links as we want between those two tables. And how do we do this? It is quite simple. So in the tables here, we'll just create a new table, and we can now, instead of having the ID as a primary key, we will have our mixed key, like a composite key. So here I'm going to have language ID, and I'm going to have a user ID. And I'm going to also have proficiency item. And proficiency is going to be the type of int, and we already know for the languages and for the user that I do have unique identifier as a key. So now I'm going to use a unique identifier for both of those values. Now the question is, should I have a default value here? The answer is no. I should not create a new value here, because every time when I create a new record in this table, this value here, this value here needs to map to the existing values that I have in the language table or in a user table. So now what I want to do is I want to change the nulls settings. I'm going to disable nulls for all those items, and I'm just going to add the references, so foreign keys. So I'm just going to go to relationships now, doing the right click, clicking relationships, and I'm going to add those relationships, same as I did before. So now I'm going to just say that I'm using the language, and the language ID is going to be mapped to language ID in this table. I haven't saved it, that's why it's called table 1. And then I'm going to use another one, and the another one is user ID is going to map to the user ID here. Now I'm going to close this, and I'm going to actually choose both of those columns, and I'm going to do right click and say set as a primary key. So now what happened is both of those columns represent the key. This enables us to have a constraint, because now John Doe will have English, but you cannot have one more record where John Doe has English. So we know that our data set is going to be completely clear. And I'm going to show you this right now. So I'm going to save this table, and I'm going to call it language proficiency. I'm going to save it. Warns me again, this is completely fine. So now I also want to have in our database diagram, which I haven't saved. Let me just try to quickly find it. Here I want to add one more table which I just created, and this is a language proficiency. And now if I move this table a bit, you will see that this table is connected both with users and the language. Pretty awesome. Great. So we already know that for languages, we have 4 of those languages. We created all 4. And for users, we have 2 users. And if we look at it quickly, the table that we have for John Doe, we see that John Doe understands English, and he's quite terrible with French. He knows bonjour, and that's it. So let's just create a record for this table. So let me just refresh this one to see we have language proficiency. And now I'm just going to do, just for fun, right click on the table, on the database, new query. The database that is being used is employees. So I'm going to say, same as I did before, insert into language proficiency. And here I'm specifying columns that I want. You can also drag and drop them. This is also quite handy, like this. And I'm going to say select, and John Doe knows English and he knows French. As I said, not so good. So John Doe, this is the user. So it represents, it's a second value. So I'm just going to do this, and proficiency for English is going to be 10. And then I'm going to have one more, which is going to be 1. And that's for French. So let me just select the languages quickly. So English is this. And French is this. So I'm inserting essentially those two values. It has a bit of a red because it probably didn't invalid object name. I think it's actually okay. Let's see. Okay, syntax incorrect. Where is my syntax incorrect? Oh, I don't need this. I don't need brackets. So let's see, is it going to be any better now? Okay, one row affected, one row affected. Don't be, sometimes the management studio gets confused, with new objects. So this is as expected. Now let me just go and see what have we created. We can do this using, let me just use designer because I don't want to confuse you. You see here, we have language ID, users, and proficiency. So now, when you look at this, it's for you, it's probably just a bit of a gibberish. And just for fun, and I'm going to close the video with this one, I'm going to show you something which is called joining the tables. And maybe it's going to be a bit overwhelming, but in next session, I'm going to explain you this a bit more in detail. So let me do this. I'm going to say select, and I'm going to say from. The select, I'm not writing anything here, but I know I want to use language proficiency, and I'm going to use something which is called alias. So I'm going to call this LP, and I'm going to use inner join to language. And I'm going to call this L on LP that language ID equals L that ID. So essentially, language ID column is going to match the ID of the language itself. So the alias of the language is L here. Now I'm doing one more join because I have one more table with user table. And I'm going to, alias for user is going to be U, and I'm saying on join me please those tables, language proficiency and user on language proficiency that user ID value needs to match user that ID value. And then what I want to select from the language proficiency, I want to say, okay, language ID, please read me now, not from language proficiency, but from language. I want to say language.name. Let's put this on the brackets and language name. And then from the user, what should I choose? I can say user.first name, and I can say user.last name. And I can, from the language proficiency, I will use man, I'm going to miss this for sure. Okay, so now I have all those 3 values, actually 4 now, and I want to see what is going to be the result of this query. You see, I'm getting the now friendly names by joining those tables. So joining tables is going to be completely different things. I don't want to do this now, so let me just do something like this here so that I just have 2 columns. Okay, and I can also use a bit of an alias here as a user. This was not Excel. Let me just see. I'm just wondering how is this going to be. Yeah. So this gives us the possibility to create John Doe values in this case, for the language proficiency. But I promised you one more thing to show you how this constraints are going to work. If I try to insert one more time that John Doe understands French as 1, if I try to execute this one, I'm going to get violation of a primary key constraint because I already have these values and I cannot insert duplicate key. Even if I change this to 5, my key consists of 2 columns. One column is a language ID and another column is user ID. And even if I look at here, I will see that I have those values and I see constraints nothing, but I see that I have those keys here. So this is actually everything that I need for me to you know to understand how the tables are working. Now I can be 100% sure that there are no duplicates, there's nothing, and I'm going to be pretty happy with this. So hopefully this is going to be enough for you to understand the basics of the databases, and afterwards I'm going to quickly show you, explain you a bit this, what are those joins, how do they work, but essentially it's not going to be too difficult. And as soon as you get this one, then I assume that it's going to be a bit easier to work with all those systems. So this is a long video, so thank you very much for your time, and have fun. Bye.